Chapter 14 review. Number 1. A pair of dice are thrown. Find the chance that both dice show 3 spots. So what's the chance that the first one shows a 3? 1 out of 6. And the second one? Is the second one independent or dependent on the first? Independent, so I do 1/6 times 1/6, 1 over 36. B. Find the chance that both dice show up the same number of spots. Well, what's the chance of rolling a particular number on the first dice? 1 out of 6. Okay. Well, let's put it this way. What's the chance of rolling a winning option on the first dice? The first dice could be anything, 6 out of 6. But the second one has to match the first one, so the second one would be 1 out of 6. So 6 out of 6 times 1 out of 6 is 6 over 36, which makes sense because in our array, if we have white dice on the side and black dice on the top, how many winning combinations are inside that? The 1, the 2, the 3, the 4, the 5, and the 6 doubles. So it'd be, you have 6 out of 36, which simplifies. Yeah. Okay. 2. In the game of Monopoly, a player rolls 2 dice, counts the total number of spots, and moves that many squares. Find the chance that the player moves 11 squares, no more and no less. Okay. Can we use the addition rule? Are these mutually exclusive? Nope. They are independent. So if we look at our, 1, 1, 1, 1, 2, 1, 3, 1, 4, and 1, 5. 2, 1, 2, 2, 2, 3, 2, 4. Oh, I need a 6, huh? 2, 5, and 2, 6. Now, I'm not going to write them all out because we don't really care. Which one of those would add up to be 11? Well, I mean, the ones that I haven't filled in yet. It would be these two, right? So 5, 6, or sorry, 6, 5. No, it would be 5, 6, and 6, 5. Those are the only two that add up to be 11. Right? So 2 out of 36, which is 1/18. Okay. Maybe when we take this test, I'll print you off the doubles chart. That'll probably help. True or false? If a die is rolled 3 times, the chance of getting at least one ace is 1/6 plus 1/6 plus 1/6. False, because they're not mutually exclusive. How would we find it? We would calculate the chance of losing, which would be 5/6 to the third, and then subtract that from 1. So finding the chances of winning is really hard because there's overlap. Because 1, 1, 1 gets counted multiple times, and 1, 1, something else gets counted multiple times. So instead of finding the chance of winning and then subtracting off the duplicates, we find the chance of losing, which losing on the first one is totally independent of losing on the second one. So we can use the multiplication rule. So the chance of losing on the first dice is 5 out of 6, and on the second dice it's 5 out of 6, and on the third dice it's 5 out of 6. When we multiply that, we end up with a percentage that tells us how often we lose. And then we just flip it by doing 1 minus losing, and that gives us the percentage of winning. Okay, B. If a coin is tossed twice, the chance of getting at least one heads is 100%. No, that's silly. Right? Yeah. You can't do 50 plus 50. Okay, 4. 2 cards will be dealt off the top of a well-shuffled deck. You have a choice. Win $1 if at least one of the 2 cards is a queen, and win $1 if the first is a queen. 1 is better. How come? And two, so if the first one is a queen, you have a 4 in 52 chance, right? But for the first one, you have a 4 of 52 chance, and the second one, you have some other chance that you would add to that. We're not going to calculate it, but it would be higher than 4 out of 52. 5. The chance of A is 1/3 and the chance of B is 1/10. True or false? If A and B are independent, they must also be mutually exclusive. False. So let's say that we're drawing numbers out of a hat. If you have a chance that 1/3 A is 1/3 and you don't replace, and B has a chance of 1/10, it would actually change, right? But they are independent, so we would replace. But if A happens, does that mean that B cannot happen? Not necessarily. So A and B can be independent and not be mutually exclusive at the same time. If A and B are mutually exclusive, they cannot be independent. So let's think of it this way. The chance of drawing a male is 1/3. The chance of drawing a female is 1/10. So male and females are mutually exclusive. Can they be independent? So, um, so if they're mutually exclusive, then A and B have no overlap, right? So if they're not mutual, so if they are not mutually exclusive, then that happens. Okay? But if they are mutually exclusive, then this happens. So is the chance of B happening influenced by the chance of A happening? It could be, right? It could happen. So we're going to say false. And please tell me that's what the back of the book says. Oh, they don't. Okay. And it's false. Yeah, the answer is false. But I'm not going to ask you that on a test. That's hard. And I don't really understand. Sometimes I get it wrong. Okay. 6. One event has a 1/2 chance, another has a 1/3 chance. Fill in the blanks using one phrase from each pair below to make up 2 true sentences. Write out both sentences. If you want to find the chance that or both events. So, okay, so you have to pick one of those two phrases. If you want to find the chance that something will happen, check to see if they are. Oh, I see. So we're doing this twice. If we use at least one of the two events. So I'm going to read this using at least one of the two events. If you want to find the chance that at least one of these two events will happen, check to see if they are mutually exclusive. If so, you can add the chances. Now let's do it the other way. If you want to find the chance that both events will happen, check to see if they are independent. If so, you can multiply the events. All right. Repeat. Oh, no, sorry. We're on 7. 4 draws are going to be made at random with replacement from the box. 1, 2, 2, 3, 3. Find the chance that 2 is drawn at least once. Okay, so we are replacing. Do we have mutual exclusivity? No, so we can't use the addition rule. When we can't use the addition rule, we multiply using your chance of losing. So the chance of winning is 2 out of 5. So the chance of losing would be 3 out of 5, and we're going to make 4 draws. So 3 out of 5 to the 4th. So what is... So, okay. So the chance of winning is 2 out of 5. But is the second draw mutually exclusive from the first draw? No, because if we replaced it, right? Okay. So we're going to take, instead of the chance of winning, we're going to do the chance of losing, and we're going to raise that to the 4th, which is 13%, and then we flip it, so the chance of winning would be 87%. Okay, now we're going to do the same thing without replacement. Okay, so what's your chance of winning on the first one? It's still 2 out of 5. And then let's say that you win. What's your chance on the next one of winning again? Well, we've already won. Okay, this one's kind of tricky. So, is your first draw is your second draw dependent on your first draw? Yes, because we're not replacing it. So how many of those options? We have 4 spaces. And if any one of those spaces is a 2, you win. No, it's 4, right? 4 draws. Yeah, we're doing draws. So we're going to create basically a 4-digit number. Okay? And we want to know what's the chance that at least one of them shows up to be a 2, and we're not going to put it in. Well, really, if I had 5 spaces, what's the chance of winning? We're not putting them back, right? We have a 100% chance of winning. How come? There's only 5 numbers in there, and we're going to draw all 5 of them. So if I get rid of that, what's my chance of winning? Good. It's still 100%. So let's say I lose on the first one and I get a 1. If I lose on the second one, that means I got a 3. And if I lose on the third one, I got a 3. Can I lose again? No. So it's 100%. Because you're only drawing 4 times. You are drawing 4 times, but you only have 5 choices, and 2 of them are winners. So you could have, tried to calculate that out, but you can just pigeonhole it. Did I tell you about the pigeonhole property? No. So the pigeonhole property says if there are more pigeons than there are pigeonholes, then every pigeonhole gets filled. So, for instance, I can guarantee that 2 people on the earth have the same number of hairs on their heads. Okay? How many hairs on your head do you think you have? A lot. Maybe 100,000? Let's go up more. Let's say 1 million or 10 million, or how about 1 billion? Would you agree everybody on earth has less than 1 billion hairs on their heads? Okay? So by the pigeonhole property, if I lined up 1 billion pigeonholes labeled 0, 1, 2, 3, 4, and so on, then at least one of those pigeonholes has 2 people in it. Because how many people are on Earth? 7 point something billion. So if I put 1 person in all of the pigeonholes, I still have 6 billion people to put somewhere. So wherever I put that next one proves that one of the pigeonholes got filled twice. So this is the pigeonhole property. I have 4 spaces and 5 numbers to choose from, and no matter how I do it, that one of the 2's has to be used. Okay. 1 ticket will be drawn at random from each of the 2 boxes shown. Find the chance that the number drawn from A is larger than the one from B. Ooh, that's tough. Okay. Wow. Um, let me. I don't. So we're on chapter 14. This might. Some of the questions I think they tossed out. Um. 4 through 11. Oh, this is one they want us to do. So, if you draw 1 from the first box, no matter what you draw in the second box, you'll lose, right? How many ways are there to do that? So if you draw 1, how many ways are there to draw 1 out of the first box? So we're going to be creating 2-digit numbers, okay? So this is the first box, 1, 2, 3, and 1, 2, 3, 4, right? If we draw 1 out of the first box, I lose. That would be 11, 12, 13, and 14, right? Darian? Okay, and then 2, 1, 2, 2, 2, 3, and 2, 4. 3, 1, 3, 2, 3, 3, and 3, 4. So you lose all of those, and you lose, well, let's talk about win. You win none of these. How many in the second row do you win? So you win when the first one is bigger than the second. So the only one you win is this one. Okay? And you win 2 in the next one, so we won 3 out of... If the first one is bigger than the second, you win. If the first number is bigger than the second number, then you win.
So 2 is bigger than 1, Abby, in 21.
Yeah. 2 is bigger than 1, 3 is bigger than 1, and 3 is bigger than 2. Okay. So in B, if A is equal to the number drawn from A equals the one from B. So how many of those happen? 3 out of 12. Okay. And A is smaller than B. Well, it's not going to be 9/12 because we have the equal to. Right? We don't count the equal to's. So it would be all of these. 6 out of 12. Okay. 10. There are 2 options. A die will be rolled 60 times. Each time it shows an ace or a 6, you win $1. On the other rolls, you win nothing. Okay, a die will be rolled 60 times each time. And then the second one, 60 draws will be made at random with replacement from the box there. On each draw, you will be paid the amount shown on the ticket in dollars. Which option is better? 2, definitely, because you never lose. Right? You always win. So you're not paying anything into the second one. The first one you pay and you either keep or lose. And the second one you just win or you get nothing. Okay, and then 11 is as far as we're going to go in this section. 3 cards are dealt from a well-shuffled deck. Find the chance that all of the cards are diamonds. Okay, are they... So you would have to do... Hold on a second. You would have to do the chance of winning raised to the third and then subtract it from 1 because they're not mutually exclusive. Okay, for number B, the chance that none of the cards are diamonds, that would just be the chance of losing, which we calculated in the first one. And then find the chance that the cards are not all diamonds. Ooh, that's tough. We'll talk about that tomorrow.